Hi everyone, we'll just start the session in some time. So today we are going to have the last session on the discussion of vectors. So in this session, right, we are going to cover the other part, which is the cross product of the vectors. Okay. So I think in previous class, a couple of students, Deepa, Shri and Arun, you guys were asking that you are able to go through the theory, understand it, but you are getting stuck while solving problems. I think, there are two ways of getting over this issue. Like, not only about you, but a lot of students, right? In the beginning, you will have this kind of an issue where you seem to be understanding theory, but you will get stuck while solving problems, or you are not able to get that initiation. For this, right, one of the method that I usually suggest, okay, to the students is what we generally call in our teaching language as the infant method. Okay, so I'll just take a couple of minutes before the other students are joining. Think about it, right? How an infant would start speaking, how an infant would start walking. They do it by observation and following. Like, if the mother speaks in a particular way, he will also try to speak in the similar manner. Same thing with walking and other aspects. The bottom line is like this. Okay, so infant method basically means, if say for example I am going to start solving problems on the resultant concept of vectors. Before you go and do the problems, right, go through at least 5 example problems. Like, I'm solving problems from concept tree material. Okay, there will be solved examples in that. Or I'm solving problems from H.C. Verma. Or I'm solving problems from Iredove. Or I'm solving problems from Resnick Holiday. I mean, whatever the standard book that you're following, or even concept tree material for that matter. Okay, for that particular concept, right, go through 5 solved examples. And this is not like you have to do like, now you will go through solved examples and then maybe tomorrow you will start solving problems. Not that way. If say for example you are going to keep a slot of 1.5 hours, half an hour you go through solved examples. So immediately you will start churning out those ideas and then go and attempt some 10 problems. So this method, right, as seen initially doing well with students who are just beginning to start solving problems. And some students, they will follow this method throughout. In the sense, they will follow this method even for the last chapters that they are going to learn. They'll keep continuing this method because this gives the initial comfort. Okay, so maybe you can try this approach. This is one approach. We call it as the infant method. Okay, if it is not working out, tell me, because this is what usually works out for the students who are just beginning. Okay, if it is not working out, then we have another method. I'll suggest that later. Okay, so we'll start off with the session, guys. We have something interesting today to cover, which is the concept of cross product. Okay, okay, so let us just get started with the idea of cross product. Okay, so when we are looking at the multiplication of two vectors, we have already talked about say for example there are two vectors a bar and b bar. One type of multiplication which we represent by using this notation. What is the notation? We will put a bar dot b bar. This is what we call as the dot product. What do we call this as, guys? Dot product. Okay, and dot product of two vectors will give us the output is what? Scalar. That is why the dot product is also called as what? Scalar product. There is one more way of multiplying vectors, and that is what we call as the vector product or cross product. How do we represent this? We'll represent it like this. If you have two vectors, right, a bar and b bar, we are taking the cross product, means we'll represent it like this. A bar cross, it will come cross. Okay, A bar cross B bar. Now why this cross product is also called as a vector product? Because the result of this cross product will be actually a vector quantity. So the result of this will be what? It will be a vector quantity. That is why this product is also named as what? Vector product. Okay. So in this session, right, we are going to learn about the vector product or cross product of the vectors. Okay. Now the cross product or vector product, by the way, this is also called in some textbooks, right? It is also called with the name outer product, but that is not very much common nowadays. Nowadays, we generally use either the word cross product or vector product. If you see some old textbooks, like maybe I think Erdo or some of the books like that, right? They will be using this kind of wording called as outer product. Okay, but otherwise, you can go on with these two names, cross product and then vector product. So we are saying that the cross product or vector product of two vector quantities will be actually what? It will be giving us the result of this will be a vector. Correct. So if you are doing the cross product of two vectors A bar and B bar, this is how we will represent it, A bar cross B bar. The result will be what? It will be a vector quantity. Means if we need to explain about the cross product value of two vectors, right, then we must tell what is the magnitude and we must also tell what is the direction. Correct, because a vector is defined by its magnitude and direction. Correct. So here look at the definition. The vector product or cross product of two vectors is defined as a vector. So the result of this cross product will be what? It will be a vector having magnitude equal to the product of magnitudes of the two vectors with the sign of the angle between them. So what is this? This A bar cross B bar is a vector. What is the magnitude of that? Remember, how do we represent the magnitude of any vector quantity? We'll put like this, right? Two vertical lines. How do we, pronounce it as? We will call it as what? Modulus. So this, what do you call it as? We will call it as what? Modulus. This represents the magnitude of the A bar cross B bar. Okay. Now look at this. The magnitude will be what? Equal to product of magnitudes of the two vectors with sign of angle between them. Means what? It will be equal to A into B into sine theta. What is it going to be equal to? It will be equal to what? A into B into sine theta. Okay. So it is equal to the product of magnitudes of the vectors with the sign of the angle between them. This is about the magnitude part. Okay. What about the direction part? Because we must also explain about the direction, right? So look at this. What are we talking about the direction here? Okay. The direction will be perpendicular to the plane containing two vectors in accordance with right hand screw rule or right hand thumb rule. So here we will see after some time what is this right hand screw rule or right hand thumb rule. But here what is the information we are knowing? The cross product direction, right, will be given by this particular rule which we are calling as the right hand screw rule or right hand thumb rule. Okay. But basically, right, if you have the two vectors A bar and B bar like this, okay, you think about the plane in which the two vectors are there, because a vector is represented by what? A line segment, right? Any vector quantity is represented by the line segment. Two line segments are there. You think about the plane. A cross B direction, right, will be perpendicular or normal. It will be perpendicular or normal to the plane that contains the A bar and B bar vectors. So like say for example, if I'm just to give you say representation, right? Let us say this is A bar vector and this is B bar. Okay, Now you can think about the plane right here. There is a plane. A cross B will be normal to the plane or perpendicular to plane. Means you have two possibilities. What are the two possibilities? Either up the plane or down the plane. Correct? Perpendicular to plane means what? Two possibilities, right? Either the direction is upwards or downwards. I am saying with respect to the plane. Okay. Whether it will be upwards or downwards, we will know once we cover this right hand screw rule or right hand thumb rule. Okay. So here we are not getting into the direction part. We are just giving some information about the direction. The other part, which is going to be discussed in the right hand screw rule or right hand thumb rule. Okay. Nowadays, we don't use much about this right hand screw rule. We use only the right hand thumb rule, because at some point of time, right, people in the regular day-to-day life, they used to work with screws a lot. So people can understand when something is discussed in terms of screw. But nowadays, we don't use screws that much, right? I mean, everything is now like, either clamped or something like that. So we don't use the screws in our daily life. So that's why the right hand thumb rule is a little bit more easy to, visualize and comprehend. Okay. So we'll go and discuss about it. But here, what is the conclusion from this discussion? We are able to understand what is the magnitude. So the cross product, which we are saying, also with the name vector product of two vector quantities, right, will be also a vector which will have a magnitude a into b into sine theta. What about the direction? We are going to learn about the direction. Direction will be given by the right hand screw rule or right hand thumb rule. Okay. Now we'll just try and solve a sample question to see if we are able to understand this concept. Look at this question, guys. Maybe once you are able to get the answer, you can type it over there in the chat window. Okay, look at this question. Two vectors have magnitudes 8 units and 10 units. What is the magnitude of their cross product if the angle between them is pi by 3 radians? Means, let's say the two vectors are what? A bar and B bar. They didn't say anything. So we are assuming that, okay, let us give them some names. First vector, we are giving it as what? A bar. Second vector, B bar. Okay. So first vector magnitude, I will take it as what? 8. Second vector magnitude, I will take it as what? 10. What other information we have? The angle between the vectors is given. What is it? Pi by 3 in terms of radians. Okay. Remember, guys, we already discussed about it. If we want to convert this into degrees, how do you convert it? We have the formula, remember? Angle in degrees is equal to what? What is the conversion? Angle in degrees is equal to what? Angle in radians into 180 by pi. Means what? Angle in radians is pi by 3 into 180 by pi. You can check it up. So pi is cancelled. 3 ones are 360. So what is the angle here? It is 60 degrees. Okay. Now let us come back to the question. What is the question? We have to find the magnitude of the cross product. Cross product magnitude we have to find. What is the formula for that, guys? This is a straightforward question. What is it? A into B into sine theta. What is the A value? We will take it as 8. B value is what? 10 into sine 60. If you are comfortable with radians, use that. If you are comfortable with degrees, use that. Okay. But after some time, we should be able to easily understand the conversion between degrees and radians. Okay, guys. So now what is it? 8 into 10 into what is sine 60 value? Remember what is sine 60 value? It is root 3 by 2. Okay. So 2 ones are 2 fours are. So what is the answer? 40 root 3. Check it up, guys. What must be the answer we should get? The magnitude of the cross product. What is the value? 40 root 3. I'm assuming you also would have got the same answer. These are straightforward questions. Next we will go to another question. See, this is what I keep emphasizing. whenever we are learning even a small concept, right, we should try and solve some problems. Then only we will be able to check whether we are able to understand this or not. Okay, let us move to the next concept. What is it? Two vectors have their dot product as 60 and the magnitude of the cross product is what? 40. Two vectors, right? Their dot product is given. The magnitude of cross product is given 40. What is the angle between the vectors? This is an interesting question. See, in dot product, remember the dot product concept, guys. What is the dot product of two vectors? What is the value of the dot product? It is nothing but, if you have two vectors, right? So here they didn't even say what are the vectors or anything. So I will just consider the vectors as what? A bar and B bar. And we will also consider the angle is theta. This is what is our task. We have to find what is theta. They didn't say anything about the magnitudes, right? So we have to assume some values, no? So let us say A bar magnitude is A, B bar magnitude is what? B. Okay. So dot product of the two vectors, what is it? A bar dot B bar. What is the dot product value of two vectors, guys? What is it? A into B into cos theta, correct? In the session 6 we have covered about it. The dot product value of two vectors, A into B into cos theta, correct? And the cross product, what they have given? Cross product magnitude. What is it? The magnitude of the cross product. What is it? A into B into sin theta. A into B into sin theta. This is given to us, right? Now, AB cos theta value is what? 60. Call it as equation 1. AB sin theta value is what? 40. Call it as equation 2. Now, from both these equations, right, we have to find what is our theta value. We don't need A and B. We need only theta value. So what we are going to do is look at this equation 1. What is equation 1, guys? AB cos theta is equal to 60. See, if you observe the two equations, right, AB is coming in first equation as well as second equation. AB is coming in first equation as well as second equation. So from equation 1, AB value means cos theta will go to the other side. AB value will be 60 by cos theta. We will substitute in the second equation. What is AB value? AB value will keep it as what? 60 by cos theta into sin theta. What is it? 40. From equation 1, we are taking the AB value. What is the AB value? 60 by cos theta. Correct. And we are just keeping that in the second equation. What is second equation? AB sin theta is equal to 40. In that, in place of AB, we are keeping 60 by cos theta. Okay. So here, check this, students. We have sin theta by cos theta. Okay. And by the way, you know, 10 6s are, 10 4s are, 2 3s are, 2 2s are. Okay. 3 into what is sin theta by cos theta tan theta? 3 into tan theta is equal to 2. Okay. So from here, we will get tan theta value is equal to 2 by 3. What is tan theta value? 2 by 3. Remember, if you are getting tan theta is equal to 2 by 3 like this, then how are we going to represent the angle? Remember, we said we are going to represent the angle by using the inverse trigonometric function. What is it? How do we represent? Remember, so tan inverse theta will be equal to what? Tan inverse 2 by, this is how we are going to represent. How you will find the inverse trigonometric function and all that, you will learn in mathematics +2 because we will have a chapter there. But in physics, right, we are just going to give the angle value, that's it. So it is sufficient if you know this is how we are going to represent the angle. So if you are getting tan theta is equal to 2 by 3, then how are we going to represent the theta value? Theta will be expressed as what? Theta will be equal to what? Tan. For writing, we will write as power -1, but we will not spell it as power -1. How do you spell it as? Tan inverse. This is actually called as inverse trigonometric function. Okay, guys. So this is the angle. This is the angle between the A bar and B bar vectors. Okay. Now these two questions, if you have any issues, okay, you can just type it over there. Otherwise, we will move on to the next segment. Okay. So when we talked about the dot product, right, we said one of the applications of the dot product is using dot product we can find what is the angle between the vectors. Using dot product we can find what is the angle between the vectors. How? If you have two vectors A bar and B bar, what is the dot product value? It is A into B into cos theta, correct? Dot product value is what? A into B into cos theta. Okay. Now from here, if you bring that A into B to the left hand side, numerator is what? A dot B, denominator is equal to what? A into B. What is the value? Cos theta. So cos theta value is equal to what? Numerator, what is there? The dot product value. A bar dot B bar means what? Dot product value of the two vectors. Divided by A into B means what? This is what? What is this? The product of, what is this? Product of magnitudes of vectors. So what is A into B? Product of magnitudes of vectors. So this is going to give us what is the angle. So from here we can find cos theta means we will be able to know what is the angle between the vectors. Now we will see how the angle can be measured by using the cross product concept. We will see how the angle can be measured by using the cross product concept. So look at this, students, carefully. So what is the magnitude of the cross product? What is the magnitude of the cross product? It is A into B into sin theta, correct? From here, same method. If you bring this AB to the left hand side, where it is going to go? It is going to go to the denominator. Okay. So look at this formula. What is the numerator? Magnitude of the cross product. Correct. Magnitude of the cross product divided by what is the denominator? Product of the magnitudes of the vectors A into B will be equal to sin theta. So from here we can find the theta value. From here we can find the theta value. So this is how we can find the angle between vectors using the cross product concept. We can find the angle between vectors using dot product concept. We can also find the angle between vectors using cross product concept. But between the two, right, this is a little bit more convenient. Finding angle using dot product is a little bit more convenient. Okay. While solving problems, you will be able to generally see that if vectors are given, right, in component form, most of the cases we will be given the vectors in the component form. If vectors are given in the component form, right, then finding cross product, because we didn't do the derivation yet, we have the derivation coming up. Okay, in some time we will do the derivation also. Finding the cross product when the vectors are in the component form will be little bit tedious than finding the dot product. Dot product is very easy. Finding dot product of two vectors when they are given in the component form will be a little bit easier than finding the cross product. Okay, that is the reason why people generally prefer getting the angle value by using the dot product. Okay, so this is about the application of the cross product to find the angle between the vectors. Okay, now when we talked about the cross product, we didn't complete the discussion about the direction of A cross B. We just said that the direction will be given by the right hand screw rule or right hand thumb rule. How will give the direction? Direction is given by what? Right hand screw rule or right hand thumb rule. So here first I will discuss about the right hand thumb rule. First, how are we going to give the direction as per the right hand thumb rule? Okay, for that, right, you can see in this representation, okay, A bar and B bar, you can just make an observation here. We are keeping the A bar and B bar as co-initial vectors. First of all, how are we keeping the vectors as? We are keeping the two vectors as what? Co-initial vectors. Okay. Now when you keep A bar and B bar as co-initial vectors, okay. So look at this. Maybe I'll just try to give a representation here also. So we can see this is, let us say this is A bar and this is B bar. Read the point here. Align fingers along the first vector. Curl them to reach second vector. Along the direction the angle is measured. Okay. Means what? We have to curl. Remember, when you have two vectors like this, A bar and B bar, this is A bar and this is B bar. Okay. The shorter path is where you will measure the angle. Correct. That is where we will measure the angle between the vectors. The shorter path between them. Okay. So we have to curl your fingers in that shorter path where you will measure the angle. When you are curling your fingers, right, the direction of the thumb will point the direction of the cross product. What is it? I'll just show you. Think about it. Okay. So let us say this bigger marker. This bigger marker is A bar. The small pen is actually B bar. Okay. Now look at it. I have kept them as what? Co-initial. They are co-initial now. Align your fingers in the first vector. That is A bar. Because remember, what do you mean by first vector and second vector? When you are writing A cross B, right? In that A is our first vector, B is our second vector, like that. Okay. Keep your fingers in the first vector. Okay. First vector. Now curl your fingers in the shorter path. You can see this is the shorter path. The shorter path, because you have two. Here there is a path. Other side also there is. That is the bigger one. We have to curl your fingers along the direction where the angle is measured. Means you have to curl them in the shorter path. When you do that, look at the thumb. The thumb is what? Pointing upwards. That is the direction of A cross B. You can see here also in this. This is A bar. So see what they are doing. They are keeping in the direction of A bar. Think about whatever the representation is given in the board, right? Look at it. We have A bar. Curl them. Look at the way they are curling in the shorter path. Curl them to reach B bar. We have to curl our fingers to reach second vector. While doing it, what is the thumb? Thumb is pointing upwards. What is the direction of thumb? Thumb is pointing upwards. Okay. Like you can see what is happening if A cross B is represented by another vector C bar. Okay. So C bar is the A cross B value. Then you can see if you curl your fingers from A bar to reach B bar, right, in the shorter path, what is the thumb pointing towards? Thumb is pointing upwards. Okay. Now, before we go and discuss more about this right hand thumb rule, let us quickly take a look at the right hand screw rule. This is, I said, not much very popular. Same concept. If you rotate the screw with your right hand, in which orientation? Same way. Like you rotate it from A bar to B bar. A bar is our first vector. A bar is what? This is our first vector. B bar is second vector. Rotate the screw from A bar to B bar. Then you rotate the screw with right hand, right? Screw will actually propagate. Propagate means what? Screw will either go up or screw will be going down. It will be going up or going down. Here you can see if you are actually taking a screw, maybe at your home if you have a screw, you can just try it. Okay, so if you rotate the screw like this, right, screw will actually be going up. Okay, so that rotation of screw using right hand, from where? From A bar to B bar. Like you see the way it is rotated here. From A bar to B bar, if you rotate the screw, right, then the way screw propagates, the way the screw basically propagates, that is going to give us the A cross B direction. That is going to give us the A cross B direction. Now, we will for some time just know, maybe we can even ignore the right hand screw rule. We can just go on with the right hand thumb rule, because if you are convenient with one of them, screw rule means not much of us will have the understanding of how the screw will move. But right hand thumb rule, right, we can do it with nothing else to be required, because we just have our hand. We can just apply the right hand thumb rule by not even having anything else. Okay, so that is why this is a little bit more popular. Now what I will try to do is I will try to explain to you the direction part by taking this example. This will make us more clear. Okay, look at this. I can talk about A bar cross B bar. I can also talk about B bar cross A bar. What is the difference? What is the difference? The difference is when I say A bar cross B bar, the first vector and second vector will be what? A bar will be first vector, B bar will be second vector. When I say B bar cross A bar, when I say B bar cross A bar, right? First vector will be B bar, second vector will be what? A bar. You see the difference? A cross B and B cross A, what is the difference? A cross B means first vector is A bar, second vector is B bar. B cross A means first vector is B bar and second vector is A bar. Okay. Now we will go and discuss about it, but before we go there, right, just quickly one concept. A cross B, what about the magnitude? I am only asking about the magnitude. What is the magnitude? A into B into sine theta. Remember the magnitude. What is the magnitude? A into B into sine theta. Correct. Now, what about the B cross A magnitude? What is the magnitude of B cross A? It is going to be what? If you just look at this, right, it will be what? B into A into sine theta. What is the magnitude of B cross A? It will be B into A into sine theta. Now, if say for example, look at the previous question, right? What is the A vector magnitude? 8. B 10. Theta is pi by 3. That is the example we took. So 8 into 10 into sine pi by 3. That is our A cross B magnitude. B cross A magnitude is what? 10 into 8 into, because it is coming as what? B into A into sine theta, right? It will be what? 10 into 8 into sine pi by 3. Are these two values same or not? So A cross B and B cross A, their magnitudes, right, will be what? Same. A cross B and B cross A, their magnitudes will be what? Same. Now this is the interesting thing. Look at it. Okay. So look at the diagram that is given here. Look at this representation. Students, closely observe it. So I am just going to replicate it. Think about it. This is A bar, this is B bar. This is what? A bar, this is B bar. We keep our fingers in the first vector. Okay, curl them. Curl them to reach second vector B bar. You can see in the diagram also. So if you curl your fingers, look at what is your thumb pointing towards. Thumb is pointing what? Upwards. You can see if you are curling your fingers from A bar to B bar, thumb is pointing towards what? Upwards. Got it? So A cross B will be what? It will be upwards. A cross B will be what? It will be upwards. Okay. Now this is more important. I just observe it carefully. What about B cross A? I should keep my fingers in the first vector. What is first vector means? B bar, right? So when I am talking about the B cross A, the first vector will be what? B bar. I should keep the fingers like this and curl them in the shorter path. Remember, this is the shorter path, right? I should curl like this. Can I curl the fingers like this? No. We cannot curl the fingers like this, right? And we are saying we should not curl the fingers in the longer path. Like this way we cannot curl the fingers because that will be the longer path. So what is the other alternative? In the previous orientation, our thumb is up. We have one more option. What is it? We can keep our fingers like this, where the thumb will be down. Now you see, initially the fingers are in the B bar direction. Curl them in the shorter path. You can see we can curl them. Like this we can curl them. We can curl them in the shorter path. When you curl them in the shorter path, right, we will be able to reach A bar. The thing is what? In doing like this, the thumb is actually downwards. Means the B cross A direction will be what? Downwards. I can show you. Look at this. Look at this. Here You can see A cross B will be what? Thumb is pointing up. Okay. If you do B cross A, we cannot curl fingers by keeping the thumb up. Other option is keeping the thumb down. We can curl fingers from B bar to A bar. So here the thumb is what? Pointing downwards. Now here we are actually starting with a different purpose. I use this to explain the direction concept a little bit more clear. The purpose which we began is to know the relation between A bar cross B bar and B bar cross A bar. We should know what is the relation between A cross B and B cross A. So what is the relation between A cross B and B cross A? See, first we said what? A cross B and B cross A, they will have same magnitude. What about the directions? If A cross B is up means B cross A is coming down. Remember guys, if A cross, I am just giving some example. If A cross B is 2 units upwards, B cross A will be what? 2 units downwards. If you remember right, we talked about the concept of negative of a vector. What is it? If you have two vectors equal magnitude, the magnitudes are equal but exactly opposite directions. Magnitudes are equal but exactly opposite directions. What do we call them as? Negative vector of each other. What do we call them as? We will call them as a negative vector of each other. Means what? Means what is it? If, say for example, we are calling A cross B as C, then B cross A, right, will be exactly what? Opposite direction but equal magnitude. So B cross A will become what? Minus C. B cross A will become what? Minus C. So look at this guys. If X bar and Y bar are equal vectors which are in opposite directions, right, what we can write? We can write X bar is equal to minus Y bar or Y bar is equal to minus X bar, like that. Similarly, we can write it as what? A cross B is equal to minus of B cross A. Otherwise, B cross A will be minus of A cross B. You can write X bar is equal to minus Y bar or Y bar is equal to minus X bar. Okay. So is it clear guys? The relation between A cross B and B cross A. If you are clear with this means, you can just mention it over there. We will go to the next concept. See, the direction part, right? We are going to do numerous problems. So when we go to the chapters, right, wherever we have the cross product concept, again and again we are going to iterate, touch upon this direction part, the right hand thumb rule. Okay, so there you will be able to, each and every time you will solve some problem, your understanding on the cross product direction will be getting better. Okay, so we'll move on to the next thing, which is about the properties of the cross product. So look at the first property. The vector product of any two vectors is always a vector which is perpendicular to the plane containing these two vectors. So that is what we have seen, right? If you talk about the two vectors A bar and B bar, then when we say cross product means either we have A cross B or B cross A. That is the cross product, right? Either we have A cross B or B cross A. If A cross B is up the plane means, in the example we saw now, if A cross B is up the plane means B cross A is what? Down the plane. But they are actually what? They are perpendicular to the plane which contains the A bar and B bar. This is one property. Okay. Next property, this is what we saw previously. The vector product is not commutative. See, remember, dot product of two vectors, A dot B value will be equal to B dot A. Dot product value of two vectors, right? A dot B value is equal to what? B dot A. Why? Because A dot B is AB cos theta. B dot A, if you are writing BA cos theta, both will be same because dot product is a scalar quantity. So dot product is commutative. So we have seen this in the properties of the dot product. But cross product is not commutative. Okay, A cross B we have seen will be in fact equal to what? Minus of B cross A. So A cross B and B cross A, they will not be equal. Magnitude wise they will be equal. Magnitude same. But what about the direction? Directions are exactly opposite. So these two are not equal. Okay. Next, the cross product of collinear vectors. Collinear vectors means what? Either they will be parallel or anti-parallel. See, if two vectors are in the same direction means what? Parallel. Theta will be equal to 0. If they are in opposite directions means anti-parallel. Theta will be equal to what? 180. Remember students, what is the cross product magnitude? A into B into sine theta, right? Sine 0 is what? 0. Sine 180 is what? 0. Sine 0 is 0. Sine 180 is 0. Means the AB sine theta value will be coming as what? 0. So this is a vector which has a magnitude 0. So what do we call it as? 0 vector or null vector. So what do we call this as, guys? We will call it as 0 vector or null vector. Is it clear? So this is what will be the cross product of collinear vectors. Remember we said one thing about the dot product. I think see these concepts, right, we should be able to quickly recall. So if dot product is 0, when dot product of two vectors will be 0? Look at the dot product value, AB cos theta. When it will be 0? When theta will be 90. Because cos 90 is what? 0. Means dot product will be 0 when the two vectors are perpendicular. Dot product is 0 when the two vectors are what? Perpendicular. Cross product will be 0 when the two vectors are collinear. Collinear means what? They are either parallel or anti-parallel. Is it clear? So this is about some of the properties. Okay. Just I'll erase some of the things so that we can see the next property. What is the next property we have here? The next property is what? The distributive law. So what is distributive law? Like we have seen in this dot product case also, we have taken this. Remember, A dot B plus C will be distributive law means what? Within the parenthesis, when we open up, we will use a distributive law. Means what is it? It will be A dot B plus A dot C, like this. Each of the terms we will multiply. Here multiplication means what? Dot product. Same way, the distributive law can be used in the cross product also. What is it? If we have A cross B plus C, if we have A cross B plus C, right, when we use the distributive law, it will be what? A cross B. So inside the bracket, whatever the terms that are there, right, we will multiply with each of the terms. So it is going to be what? A cross B plus A cross C. If you have it like this, I'll just give you an example. So if you have A cross B plus C plus D, then what is it going to be? A cross B plus A cross C plus A cross D, like this. Dot product and cross product, both of them, they satisfy the distributive law. Commutative law is only for what? Dot product. Cross product does not satisfy the commutative law. Okay. Now we will go into the next property. What is it? Associative law. This is also a property that is shown both by the dot product as well as the cross product. Both of them satisfy this law. So what is this? Look at it now. If you have two numbers m and n are what? We can call them as what? Scalars or numbers. Okay. And A bar and B bar are what? A bar and B bar are vectors. Then if you have the multiplication like this, m into A bar cross n into B bar. The idea of the associative law is the m and n numbers can be interchanged, means what? The value will be same. If instead of m we have n here, like say I'll just give you one example. Let us say 2a bar cross 3b bar. This will make us a little bit more comfortable. If you have 2 into a bar cross 3 into b bar, like that, there is a cross product relation. Then the numbers can be interchanged. It means what? The value will be same. Even if we take it as what? 3 into a bar cross 2 into b bar. The value will not change even if we just, because the 2 3s are what? 6, right? We can multiply the 6. We can keep it as what? 6a bar cross b bar. Or it will be a bar cross 6b bar. Because after all the number, right? 3 into 2 or 2 into 3, that will be 6 only, right? We can keep it anywhere. This property is what we will be calling as what? Associative law. Remember, no, we have seen this in case of our this thing. Which one? The dot product also. We have seen this in the dot product also. See, that's what the main thing is. We should be able to keep correlating. Otherwise, it will appear. Otherwise, it will be appearing like, okay, we are seeing a lot of things. Only when we correlate the concepts, right, it will make things easier for us. Sometimes, I mean, not recently, but there have been even questions on some basic properties of the vectors. But if there are some questions like that, right, we should be able to easily grab those kind of opportunity. Okay, so now we'll go into the next major area. What is it? The cross product of unit vectors along the positive x-axis, positive y-axis, positive z-axis. What do we call them as, by the way, guys? We'll call them as what? I cap, j cap and k cap. In this there are two things. First is the cross product with I cap with itself, j cap with itself, k cap with itself. That is one. Second is the cross product between them. First is what? I cross I or j cross j or k cross k. Second thing will be the cross product between them. Okay. But before we go to the discussion, look at this. Already we are presenting the answer. What are we saying? We are saying I cross I will be 0. J cross j will be 0. K cross k will be 0. Why? Think about it. What is I cross I magnitude? What is I cross I magnitude? You tell me. What is I cap means? Unit vector. Another I cap means unit vector. Okay. Into sine 0. Because I cap and I cap, they are in the same direction, right? Angle between them will be 0. Sine 0 is what? 0. So I cross I will be equal to what? 0. Same thing for j cross j. Same thing for k cross k. So I cross I will be what? 0. J cross j will be 0. K cross k will be what? 0. Okay, guys. Now we will see the other thing. Other thing is what? What about the value of I cross j or I cross k, j cross k? Before I'll explain those values, let us look at how these I, j and k are actually represented. So we will call them as what? Orthogonal triad. I, j, k, we call them as what? Orthogonal triad. Remember. So if you have positive x-axis, that is the direction of I cap. Positive y-axis, that is the direction of our j cap. Positive z-axis, that is the direction of our k cap. The orthogonal triad means what? They will be mutually perpendicular. They will be what? Mutually perpendicular. Okay. They will be perpendicular in such a way that, look at what is I cross j. For example, think about I cross j. I cross j, what will be its magnitude? I is a unit vector. J is also a unit vector. What about the angle between I and j? 90. So I cross j value will be magnitude. What is the magnitude? 1. I cross j magnitude is what? 1. Now just think about it. If we keep our fingers in the positive x, curl them reach positive y, you know, the thumb will be indicating in what? Positive z axis direction. The thumb is going to be indicating in the positive z axis direction. Okay, just understand this concept, then I'll tell you easy way to remember it. If you do I cross j, that will be a vector with what is the magnitude? 1. Direction wise, right? If you curl the fingers from positive x axis to positive y axis, the thumb is going to be in the positive z direction. Means I cross j is a vector with 1 magnitude in the direction of positive z axis. What is it? It is nothing but, what is it? What is the vector which is having 1 magnitude in the positive z axis? That is k cap. I cross j will be what? K cap. Okay, now I'll tell you a easy way to remember, because you know, we don't just have I cross j, we can be given I cross k, k cross I, j cross k, like that they can ask anything, right? We should actually be able to remember. How are we going to remember easily? We can remember it easily by using what I call as this anti-clock rule. It's a very simple thing. Okay, so think about this, you know, anti-clockwise circle. Okay, put it like this: I, j, k. That's it. Now I'll tell you easily how we can write all these relations. Is it clear, guys? What are we going to do? We have to simply put the circle in the anti-clockwise direction. We have to write ijk. That's it. Once we complete it, once we write ijk, now see what I am going to do. If you start from I cross j, it will be what? K. So I cross j will be what? K. Okay, now j cross k, that's why we are calling it as what? Anti-clockwise. We have to go in the direction only. J cross k. J cross k, what is coming next? I. Okay. K cross I. If you do k cross I, what is going to come next? I cross j. Maybe you can also try it once, because you know, these easy methods to remember, right? You should practice it once. The moment, you know, I show you guys in the class or something, you should just try and practice it one time by yourself. Okay, so what is it? Again, I'll probably explain it. What are we going to do? We'll draw the things in the anti-clockwise panel. Okay, you can see in the anti-clockwise panel, we are just keeping it as what? The I, j, k, we have to keep them in the panel. Okay, so I'll just put them in the panel one more time and then explain it to you. So what is it? We have what? I, then j, then k. That is the panel. So if you do I cross j, what is going to come next? So I cross j means what? K. Done. Then j cross k means what? What is going to come next? If you move from j to k means what is going to come next? I. Okay. If you move from k to I, that is our k cross I. If you move from k to I, what is going to come next? So I cross j will be k. You will not remember it like this. You will not remember like, okay, I cross j is equal to k, j cross k is equal to I, like that. You will remember this panel. Now if you remember it, think about it. Instead of I cross j, we have j cross I. Imagine j cross I. What will be j cross I? Use that relation between a bar cross b bar and b bar cross a bar. What is the relation? B cross a will be what? Minus of a cross b. Means if I cross j is k, means j cross I will be what? Minus k. If j cross k is I, see, you are not supposed to remember any of them. You will just derive them everything by the panel. Okay. If j cross k is equal to I, means what? K cross j will be minus I. K cross I is j, means I cross k will be what? Minus j. I cross k will be what, guys? Minus j. So you will not remember these things like, by hearting method. You just try to remember the panel. Okay, the way we will keep them in this anti-clockwise panel. And every time we have to probably derive this, you will just quickly put the panel and then write the values. Okay, so is it clear, guys? This is what is going to be the cross product between unit vectors along the positive x direction, positive y direction and positive z direction between I cap, j cap and k cap vectors. Okay, so if it is clear means we will go into the next important concept. Okay. Good. So let us move to the next one. Guys, this is the most important part of the entire discussion. What is it? Finding cross product of two vectors in the component form. What is it? Remember, we talked about the dot product. If you have two vectors, like a bar is equal to ax into I cap plus ay into j cap plus az into k cap. B bar is equal to what? Bx into I cap, by into j cap, bz into k cap. Like that we have two vectors which are in the component form. Then we are now going to find what is a cross b. We did the similar derivation for a dot b. And for this derivation, right, we are going to use the distributive law, associative law and the cross product relations between I cap, j cap and k cap. Three things we are going to use. What are the three things? Distributive law, associative law and then the cross product relation between I cap, j cap and k cap. So look at this, guys. What is a bar? Ax into I plus ay into j plus az into k cross bx into I plus by into j plus bz into k. Now remember what we are going to do in the distributive law. Take the term ax into I, multiply with each of the terms. Here multiplication means what? Cross product. Cross product with each of the terms of b bar vector. Means look at this, guys. Ax into I cross bx into I plus ax into I cross by into j plus ax into I cross bz into k. Guys, you know what I suggest is you try to do the derivation along with me so that you will also come along. Okay. So here we are going to use the associative law. Remember, if you have the numbers m and n, we can keep the m and n together. So just look at this, guys. Ax into bx I cross I plus ax into by I cross j plus ax into bz I cross k. Okay, so we are just using the associative law. Now remember what we had? We had this relation between our, what are the things? That anti-clockwise I, j, k. Okay, so look at this, guys. First I cross I is what? 0. I cross j means what? Remember, I cross j will be what? K. So this is what? Ax into by into k cap. Okay, I cross k is what? See, k cross I will be j, I cross k means opposite, right? It will be what? It will be minus j. So it will be what? Minus j. See, I am not remembering anything. I am just trying to get the values from that anti-clockwise circle. K cross I will be j. I am not having k cross I have a I cross k means it will be minus j. So that's why it comes minus j. Correct. So first term is 0, second term is there, third term is there. Now what I will do is I will just erase some part of it so that we can write the values, what are coming. We just did one step of multiplication. We have totally how many steps of multiplication? 3 steps of multiplication are there. Correct or not? We have how many steps? 3 steps. So look at this, guys. What is it? Ax by into k cap, and then minus ax bz into j cap. This is minus because we are having minus j. Okay, this is what we are getting after the first step of multiplication. Now you guys have understood the method. So can you parallelly work along with me for the second step of multiplication? What is second step of multiplication, guys? We will take ay. What are we going to take here? We will take this one, the second term, ay into j, and then do the cross product with each of the terms in b bar vector. Look at this, ay into j cross bx into y plus ay into j cross by into j plus ay into j cross bz into k. Again, associative law, ay bx j cross I. Okay, ay by j cross j, ay bz j cross k. What is j cross I? Remember, I cross j is what? K. J cross I means what? It will be minus k. J cross j is 0. J cross k. What is j cross k? That will be I. So after this, what are we having? Look at this. I'll again take the terms and then write them at the top. Okay. So this is not a difficult derivation. It is just that we have to do it. Okay. So look at this, guys. This is what? Minus ay bx into k cap. This is minus k cap, plus ay bz into I cap. 2 steps are over. Now what are we having? The third and final step of multiplication. So look at this, guys. I'll erase this again. Now we can do the third step of multiplication. So we are just doing one by one step. The derivation, right, as I said, is not a tough derivation or anything. But here the important thing will be how are we going to remember the final result. Okay, so look at this, guys. Az into k cross vx into I plus az into k cross by into j plus az into k cross bz into k. Associative law, az bx k cross I, az by k cross j, az bz k cross k. What is k cross k, guys? 0. K cross k is what? 0. What about k cross I? K cross I will be what? What is k cross I? J. K cross j, see, j cross k is I. K cross j will be minus I. So this is going to be what? Minus I. So we got our terms. I will write them at the top. Look at this, guys. What are the terms that we got now? This is what? Az bx into j. Then minus AZBY into I. Okay, so now we have come to the final step. What is the final step? If you see, there are how many terms? How many terms are there, guys? There are actually 6 terms. It is looking like how many terms are there? 6 terms are there, correct? But the I cap terms are 2, J cap terms are 2, K cap terms are 2. Means we can keep the I cap terms together, J cap terms together, and then K cap terms together. Okay, so what we are going to do, just keep the I cap terms together. What are the I cap terms? This is, where is that? This is an I cap, this is an I cap, correct? So AYBZ minus AZBY, because this is plus I cap, this is minus I cap. That is our first term. Okay, I'll try to write with different colors so that it will be easy for us to. Then comes J. Where is J? This is one J, this is another J. Okay, so look at this, guys. AZBX minus AXBZ into J. Okay, then what is it? The last. Here K, here K. AXBY minus AYBX into K. What is it? AXBY minus AYBX into K. Okay, so this is what is the final result of the cross product. This is what is the final result of the cross product. Okay, now the thing is, some people try to remember the formula as it is, but once you come to in +2 mathematics, right, you have a chapter called as determinants. In the chapter, right, there will be something called as the determinant value. That is something that you are going to learn, and you will do a lot of problems on that, like finding determinant of a matrix and all that you will learn. Okay, there is a easy way to remember this cross product final value by using the determinant formula. There is a easy way to remember it by using what? Determinant formula. See, all this time what we did the derivation. You are not going to, in no problem, you will be supposed to do the derivation again. The derivation you will probably do it only once, and maybe, not even probably in school exams or sometimes you may be able to get it. But why are we doing the derivation? That is more important, to know really how the final formula is coming. Okay, so now we got understanding of how the final formula is coming. Now what is our job? How are we going to remember this formula? Because when we look at the questions, right, nobody will probably ask us to do the derivation, but they will ask us the questions like, okay, there is a vector A bar and there is a vector B bar. They will give us the vectors in the component form, and they will ask us to find what is the cross product. They will ask us to find what is the cross product value. Like that we will have questions. Okay, the thing is, how are we going to remember? So either some people try to remember this formula, or this is the formula, by the way, I'm just writing it again here. This is the formula. Okay, we can also remember the formula by using the determinant concept. We can also remember the formula by using what, guys? The concept of the determinant. Okay, so how are we going to remember the formula? By using the determinant concept. Okay, so this is a very simple thing. So what is the determinant? It is the value of this particular representation. So we'll have first row. The horizontal lines will be called as what? Rows. First row will be I, J, K. Second row will be what? The first vector coming is A bar, right? The components AX, AY, AZ. Second vector coming is what? B bar. B bar components BX, BY, BZ. That is how we are going to first of all represent. Determinant will be represented like that. Okay. Once we do the representation, once the representation is done, okay, then the I cap, you have a factor. J cap, you have a factor. K cap also have a factor. This is how you are going to get the factors of I cap, j cap and k cap. For getting the factor of I cap, right, you have to remove the row and column elements. In that I cap row, there are I, j and k. Forget about them. Column also, forget about it. This is the remaining part. What is the remaining part? You have 4 values. The 4 values, right? Remember, you can check them like this. Like this, you can see, right? 1, 2, 3, 4. You can see it like 1, 2, 3, 4, or you can even write it like this: 1, 2, 3, 4. Either way, like this: 1, 2, 3, 4, or 1, 2, 3, 4, whichever way. Okay. The factor of I cap, right, will be, the I cap factor will be AY into BZ. Look at this. It is like what? 1 into 4. 1 into 4 minus AZ into BY. 2 into 3. 1 into 4 minus 2 into 3. So 1, 2, 3, 4 are what? The symbols we are giving for them. Okay. So it will be what? 1 into 4 minus 2 into 3. So it will be what? AY BZ. You can see it is what? AY into BZ. 1. First term is what? AY. Fourth term is what? BZ. So AY into BZ minus. So you can see blue color is positive and red color is what? The orange is basically negative. Okay. So 1 into 4 minus 2 into 3. 2 into 3 is what? AZ into BY. That is the factor for I cap. The factor for I cap and factor for k cap, right, will come similar manner. But only difference will be the factor for j cap. Look at this. When we are going for j cap factor, this is the row which has j cap. Remove the elements of the row. Same, the element in that column, remove them. Now look at this, what we have. AX, this is what we have, right? Look at this: AX, BX, AZ, BZ. Here the difference is, it will be, the factor will be 2 into 3 minus 1 into 4. So look at this. What is the 2 into 3? AZ BX. 2 into 3 is what? AZ BX. Minus 1 into 4 is what? AX BZ. Only thing is, in case of J cap, it will be what? 2 into 3 minus 1 into 4. Okay. Now I'll show you K cap. This is, I said, similar to I cap. Look at this. The column and row, remove them. Remaining are these. Here again, what comes? I said 1 into 4 minus 2 into 3. Right? Look at this. What is 1 into 4? AX into BY. Minus 2 into 3, which is what? AY into BX. So for I cap and J cap factors, it is what? 1 into 4 minus 2 into 3. For J cap factor, for I cap and K cap, it is same. 1 into 4 minus 2 into 3. J cap only, it is what? 2 into 3 minus 1 into 4. Okay, so K cap also, what is it? I'll just write it here. K cap also, what is it? It will be what? 1 into 4 minus 2 into 3. Only J cap, it will be different. Okay, so this is how you can remember the value. And because why this determinant is explained to you now, because you didn't cover the determinant in mathematics, but again I am telling it to you now. Why? Because you are anyway going to learn about it in mathematics. The chapter name itself is matrices and determinants. So you can think about it, right? This determinant formula, this is actually called as a 3 by 3 matrix. You know what it will be called as? It is called as a 3 by 3 matrix. So at least some 100 and 200 problems you will solve on this determinant value minimum. So you think about it, how convenient you will become to write the value. So even though it is initially taking some time for you to write down the value of cross product by using the determinant formula, you try and use this, because once you go to mathematics matrices and determinant chapter, right, this concept you will be anyway using number of times. So you will get that much more comfortable with it. Okay. So in that foresight, we are trying to learn this formula for the cross product using the determinant. Okay. But remember, what will be our main task? The main task will be questions like this. Like they will ask, if there is a vector, I'll just show you. If there is a vector 2i cap plus j cap plus k cap, and there is another vector I plus j plus k, something like that. Okay, they are giving two vectors. They will ask us what is A cross B. So this is the kind of questions we must be able to answer. Now you guys have seen that formulas. Can we try and do this value? So maybe I'll just show it to you. So I'm putting the determinant I, j, k, first row. Second row is what? The A bar components. What are those? 2, 1, 1. Third row is what? B bar components. B bar all are what? 1, 1, 1. Okay. Now we'll start. What is it? Remember, when we have to find I cap component, we have to cover that row, cover that column. If you cover the row and cover the column, remaining elements are these are 1, 1, 1, 1. These are the 4 elements. Correct. So what is I cap factor? 1 into 4 minus 2 into 3. Remember the formula. So 1 into 1 minus 1 into 1, which is of course 0. Means I cap component is what? 0. Then we'll do the j cap component. We'll have to cover this row and column. See, look at this where I'll write j cap will be like this. That row and column we have to forget. Remaining elements are what? 2 and 1, 1 and 1. Like this it will be remaining. J cap, remember guys, what is the formula? It will not be 1 into 4 minus 2 into 3. It will be what? 2 into 3 minus 1 into 4. Reverse it will come, which is 1 minus 2 minus 1. So I am writing the final answer. I cap, what is the factor? 0. J cap, what is the factor? Minus 1. Now last comes K cap. Look at this. K cap, forget about the row and column. So K cap, if you forget about the row and column, what will be remaining? 2, 1, 1, 1. Here what is the formula? 1 into 4 minus 2 into 3, which is 2 minus 1, 1. Means K cap, what is the factor? 1. So it will be what? 0 into I cap, means there is no I cap at all. Plus minus 1 into J cap, means that is minus J cap. Plus 1 into K cap means what? K cap. So what is the final answer guys? Minus J cap plus K cap. Maybe you can also try it and check if you are getting the same answer or not. Okay, you guys have to tell me if you are getting the same answer or not. But you need to practice it. So how you will write the determinant formula, and then like the way I am able to do it fast, right? If you practice this means you will be also able to get this in a quicker manner. That is more important. Okay, and with accuracy, not making mistake. Because after learning all the things, right, like say for example, we will see when it comes to the applications, what will be the applications of the cross product. What will be the applications of the cross product? When it comes to the applications of the cross product, right, we will see if the cross product value we are getting it wrong, means everything will go for a toss. Like I'll show you one of the applications in physics, right? What we have in physics. This is an application we have for the cross product in physics. Look at this. The torque that is given by force. Torque is called as what? Turning effect. So if there is a point, okay, so where we are applying a force, you can see, like say for example, this is the axis. This is the axis. We apply force at a particular point. We apply a force. So this R bar is what you know. It is basically what we call as the position vector of point where the force is applied. Okay, so don't bother about these things because we will learn about it. When we go to the torque in rotational motion, we will learn about it. Okay, but just remember the idea, right? So if we look at torque as a physical quantity, turning effect of force, it is given by R cross F. What is R cross F means? R bar is position vector of the point where you apply the force, and F bar is the force vector. Okay, so in the visualization that is happening, they are giving us what is the, like in the first case, right, R cross F, cross product is up. If you apply the force other way means the thumb is down. they are giving you the direction of the torque. They are giving us what? If you apply the force like this means thumb is up, you can see. That is R cross F direction. If you apply the force like this means thumb is down. Okay. So the turning effect of force is given by what? Torque. It's a physical quantity. And how are we going to measure the torque? R bar cross F bar. What is R bar? From the axis of rotation, the point where the force is applied, right? That particular point, position vector. We'll draw a line from the axis to the point where the force is applied. That is the position vector. We'll do R bar cross F bar, right? That is going to give us the torque. Means if R bar is known and F bar is known, right? How we will find the torque? We'll find the torque by taking the cross product. We'll find the torque by taking what? By taking the cross product value. Clear? So this is the kind of applications we will have for the vectors. I mean, not just this torque concept. Like we'll see so many other formula where the cross product is going to be used. So the dot product value and cross product, right? These two are very important relations that we will be having between the vector physical quantities. We'll see a lot of relations. Okay, when we go into the respective chapters, we'll see a lot of relations. Okay. So anyway, so we'll conclude it here, guys. The idea of vectors, we have, I think, discussed about the vectors and the concepts related to vectors in detail. And maybe now at least you can go back and solve that assignment that is given to you. And also you can check with me if you have any doubts on this. Okay. And in the next class, right, we are going to start with the other chapter. Okay. So we'll see in the next class, guys, then.